to negative or negative to positive. So you have to set the, what's the first thing you do? You set the derivative equal to what?
0.
You set the derivative equal to 0, exactly. So that's right here. Here's where the derivative is equal to 0. So there's two things, x squared plus minus 10 is equal to 0, and 2 to the x equals 0. 2 to the x can never equal 0.
So what do you do about that?
Nothing. It just can never be 0. So the only way it can be 0 is right here, plus or minus 10. So where do they go? Negative root 10 and positive root 10. So then you test values and you find that it's positive here. It's, oh, that's 2 to the x, I'm sorry. 2 to the x is always going to be positive, but what happens with x squared minus 10? It goes negative, it goes positive, negative, positive, like this. Cool, it mixes colors nicely. So what happens here? What do you know happens here? There's going to be a what? What? No, at, it's going to be a turning point, but it's going to be a what? It's going to be a max, and then it's going to be a min. It's important, they do a double, she does a double, in this answer key, it's a double sign diagram. And the reason she does that is this is just used to plug it in. So if everything's positive here, what happens when you multiply a positive number times another number? What happens to, so if A is positive or negative and you multiply it by a positive number, what happens to the positivity or negativity of the first number? Nothing. Can a positive number ever change the sign of another number by multiplication? No. So the only thing that dictates the sign is this, x squared minus 10. So you do a sign diagram here, it goes positive, negative, positive. Positive, negative, positive. The other thing is you can just plug, if it's clearer for you, just what's a number, what is root 10 about? What's negative root 10 about? 3 point something, right? Yeah. So plug in like, I don't know, negative 5. Plug in negative 5 into this. Well, this is going to be positive, and that's going to be positive. So the whole thing is positive. Plug in, what's between these right here? What's between negative root 10 and root 10? 0. Plug in 0. Anything to the 0 power is 1. 0, oh, it's going to be negative 10. So it's negative here, and then what could you plug in over here? 4 or 5, right? Plug in 4. Plug in 4, you get, 16 times 6. Is that positive? Yes. So just take it carefully. And just to answer your question, it's totally okay that it's never equals 0. So the other thing is what makes it equal 0. Shall we? I'm going to label it 7.5 comma negative 8. I'll just label that point for us. Okay, so if we have this here, if you want to do this answer, you do them in interval notation. So what's the interval for positive? Say it again, Jen. 4 to what?
4 to 6.
And what's it for negative? 0 to?
Negative 4.
0 to 4.
0 to 4. Union with 6 to 7.5.
Yes. When is Bill's velocity greatest? Can someone tell me when is Bill's velocity greatest? When is the velocity greatest? Zach. When does it look like the velocity is greatest? 4 1/4? Yeah. Remember, this is the velocity graph. So this question is asking, when is this graph the highest? That's all that question is asking. Oh. This is the velocity graph. So when is it highest?
5.2.
Or let's just go to 5. Yeah. Let's call that point right there 5 comma 1.5. So that's going to be time equal what? 5. When is Bill's velocity least? Can someone tell me when Bill's velocity is least? Connor. No. No, it is not. 7.5. Oh, you can't see that? Oh, sorry. 7.5. And what is the velocity at 5? 1.5. And what's the velocity at 7.5? Negative 8, based on those points that I put in there. When is Bill's speed greatest? What's the relationship between speed and velocity? What does speed equal in terms of velocity?
Absolute value.
The absolute value of velocity. So when is the absolute value of this the greatest? When is the... Exactly, t equals 7.5. Because what's the absolute value of negative 8? 8. What does the absolute value function look like? You see all the blue shaded right here? What does the absolute value do? Flips it up, right? So this thing would spike up. It would go all the way to negative 8. And here, what's the velocity? Negative 6. So if you do the absolute value, it's going to be larger. You can sit down now. Thank you for paying attention. So what about this one right here? When is Bill's speed least? What's the smallest speed something can have?
0.
0. Because can speed be negative?
No.
So if you have a speed of 0, you can't go any lower than that. So can someone tell me where the speed is 0?
And t is 4.
Or?
Or 6.
Yes. Because here, the velocity is 0. Excellent. It's right here and right there. Very good. During what intervals is Bill's acceleration positive? So what function is acceleration tied to?
The double.
Double derivative, right? This is the single derivative because this is velocity, right? What is the derivative of velocity? Acceleration. So if we want to know when the acceleration is positive, we want to know when the derivative of this is positive. Can someone tell me when the derivative of this is positive from where to where?
From
Let's say that's 1.5 comma negative 5 3/4. So from there to where? To where? Yeah. So from 0, so there to 5. Excellent. And then where's it going to be negative? Everywhere else, right? This right here, Nick, this right here is, this is the velocity graph. The original graph is velocity. What's the derivative of velocity? Acceleration. The derivative of velocity is acceleration. So if we want to know where the acceleration is positive, we want to know when the derivative of this is positive. So the original function here, the black, where is the derivative of the black positive? Well, that's the green, where it's going uphill.
Yeah.
So that represents where the acceleration is what? Positive. This is where the acceleration is negative. So let's write out those intervals there. Let's write out those intervals. So where is it positive? It's positive from, what did we say? Was that 1.5 to what? 1.5 to what? Speed is increasing when what is true?
velocity.
V of t and A of t have the same what? Yes. They have the same sign. And this one is when V of t and A of t what? Have different signs. Different signs. So you have to look at this and remember, so positive in this case, positive is going to be, you have to be very, very careful about this. So let's see, when are they both positive? Positive is green and what? That was positive second derivative. And where is it? Where is positive for the for velocity?
Yellow.
Yellow. So where is it green and yellow? 4 to 5. So that's one of the regions the speed is increasing, 4 to 5. So both positive is 4 to 5, and negative is blue and what?
Purple.
Where's blue and purple?
0 to 1.5 and 6 to 7.
What is it?
0 to 1.5.
0 to 1.5, yep. So both negative is 0 to 1.5, and where else? 6 to what?
7.
6 to 7.5. Union 6 to what? 7.5. Does that make